Alright everybody, Mr. Barry here. Want to go over some of the most common mistakes from the first check. We do have the piecewise function, assessment quiz, major score, whatever you want to call it, on the way here. If you hear a screaming baby, it's because I'm holding my 1 week old in the back. He's sleeping now. We'll see if the math wakes him up. So anyhow, let's go over some common mistakes. For this first set of problems, we have this image here. We have these three pieces for this piecewise function. And there are a bunch of problems off of it, but the two things we're going to focus on in this video is what's going on at f of -4. And we're going to go ahead and focus also on if we knew f of x is equal to 5. So let's talk about the one that appeared first, which is f of -4. The -4 here is our x value. That's our domain. So we're looking specifically at this location where the x value is -4. Now, a lot of you, there were a litany of different mistakes that occurred here. But we're really kind of focused on those two situations right there, those 2 points. So we do have a point at -4, comma 1. We have a point at -4, comma 2. So we had some people just answer 1. We had some people answer 1 and 2. And both of those answers would be incorrect. So it is not just 1. It is not 1 and 2. The actual answer here is just 2. Now remember, this has been brought up, I believe, in some of the Nearpods. But when we're looking at these dots, we need to understand that if I have a dot that is not colored in, it's called excluded. And a dot that is colored in is included. Alright, general rules for a function we learned back in Algebra 1. We can't have points stacked over top of each other. That's impossible. It's not a function if that's the case. And here we have 2 points topped over each other, but we have an excluded point that's not colored in. That means it does not count. Alright, so even though we have that physical representation there of that dot at -4, 1, it doesn't count towards us. It's an open dot. So our answer here is just 2. On the flip side of that is f of x is equal to 5. We are looking at a y value here. So this is a scenario where we're talking about y is equal to 5. So I'm going to go look at this location right here. Some people just have this point right here. They just answered -1. And some people gave me just -3. But in this scenario here, it is okay to have multiple x values that lead to one y value. So in this case, we do have 2 answers. In this case, we would have that x is equal to -3 and also -1 for that. So certainly kind of sort of a tricky set of questions. I get it. But let's make sure we're paying attention. Are those dots included and excluded? The excluded ones don't count for us. And then, of course, if I'm looking and I'm given f of x is equal to a number, looking for y value equal to a number, that x value can be multiple numbers in that scenario, which was in the pink. Continuing on, some of the common mistakes that occurred throughout the check, want to make sure we're okay with. We had these 4 problems. It was a multiple choice scenario, and I believe each option had a all answer possible also. So the first one, I believe, was the domain. The domain going from negative infinity all the way to positive infinity. Alright, so when we're talking domain, we're talking about left and right. And the big key here is I want to go ahead and pick out my arrows. So here arrow's going to the left. Here, the arrow's going to the right. Here, the arrow's going to the left. Here, the arrow's going to the right. Here, the arrow's pointing to the left. This one's going to the right. You probably see the pattern occurring here. There's left, and there's right. So in every one of these problems, the arrows are going in both left and right directions. So our options were the first graph, the second graph, the third graph, the fourth graph. In this case, option 5, all of these are going from negative infinity to positive infinity. There is some spots, of course, we want to pay attention. For instance, right there and right there, where we've got to be careful, make sure that we do have an included dot stacked, and in both scenarios we do have an included over top of an excluded. If those were two excluded points, then there would be that occurrence of not having a location, having a domain at a specific spot, but that's not the case here. So option 5, I believe, was our answer. Then we talked about range, and we wanted to know. We wanted to go negative infinity, and then we're talking y, of course, for range. And in this scenario, we wanted to know if any of these went from negative infinity to positive infinity. So when we're talking range, we're talking about up and down. So let's go ahead and write this out. The first option here, down, up, down. Now this one over here that was going to the right in the second option doesn't have an up, doesn't have a down. Here we're going up and up. Here we're going over here for the fourth option. No up or down for the first one. The second one is going down. So in this one, is any of these traveling from negative infinity to positive infinity? In fact, they are, and that would only be option number 1. So option number 1 here is going up and down. It is going from negative infinity to positive infinity just for the y value. There's no stopping in between. Finally, one of the last ones that was kind of common. This is definitely a tricky problem, to say the least. I definitely get that, and be one of those ones that might be kicking yourself on. But we had a piecewise function that we had to evaluate. I believe this is something to do with insulin getting put into the body for somebody who's diabetic. And the insertion started at 6 a.m., which is a big deal here. So, numerically speaking, that starting location of 6 a.m. is actually t is equal to 0, which means in that very first question, 7 a.m., t would be equal to 1. 1 hour has passed since the insertion and the distribution of this insulin. So a lot of us here in this problem got things messed up because they were looking at the actual number of the time of day, so the 7. So a lot of people for 7 a.m. Said 220 because they thought that t was equal to 7 because of the 7 a.m. And that's just not the case, because the wording of the question said hours since the distribution started. So in this case, we're looking at t is equal to 1. We're actually right here. We're taking the number 1 and plugging it in for t. We're doing a little bit of math work, and the answer here would be 140 for that first question. So in that set of problems, a lot of repeating issues. If that's something where if you were not tracking time, you might have lucked out once or twice. But generally speaking, mistakes were made there as well. So that's just a summarization of some of the issues that popped up on this piecewise check. The game plan here is to wrap up applications and get our first major assessment, quiz, test, whatever you want to call it, at the end of this week. If you have questions on any of these things, please email me, and I will make any notes where need be with that. So we will talk to you later. Have a good day.